Okay, I think we're ready to start the final session of your week. I know you guys have been uh, had like lots of information this past week, and thank you for seeing the week through with this final event. And I think we're about to start just when folks have come in. We tried to ask if they could adjust the temperature. Unfortunately, they said they couldn't. So we'll just open the doors if it's too cold, you know. So we could probably shift through to the ADB folks. Um, all right. So everyone seated now. I think we'll call on Miss Lilith, our MC for the afternoon. She's all the way in Manila. Cindy and Lilith were here earlier in the week. I don't know if you remember. Yeah, you've met them. Go ahead, Lilith. You're on screen now. We can see you. Yeah.
Yes, thanks, Mike. Good afternoon to all from Manila, Philippines, and good morning to you who are joining us from Europe, and good evening to some of you who might be joining us from Australia and the Pacific. My name is Lilita. I am Knowledge and Capacity Building Consultant with the Emerging Areas Energy Sector Office at the ADB. I'm pleased to welcome you to this knowledge sharing event, which is the fourth of webinars hosted so far by the Emerging Areas team. And in today's program, we will be joined by our host, Asian Development Bank, to open the session, followed by the panel presentations on MRE and Blue Economy and a Q&A session thereafter. We are happy to have a panel of distinguished speakers who will be calling in from the United Kingdom to talk about marine renewable energy and blue economy. And I'm happy to also see our friends from the Pacific Islands and Central and West Asia, who over the past week have been attending the AIX ADB sessions and the FinTech Festival in Singapore and have
Lilith, maybe they
taken
wanna say hi. They are on camera here. Say hi, guys.
hello.
Yeah, there you go. Yeah, they can see you.
Yeah.
So time to be
Thank you so
alert.
much for taking time to huddle over there in Singapore and join us in today's webinar. Thank you all for your presence. So, as you know, this webinar is being recorded. And for any questions and comments from our online audience, I think right now we've got about 19 participants online. We would encourage you to kindly raise your questions through the question and answer board on the Zoom screens. And if you could also include your name and affiliation, that would really be great. And our panelists will then be able to respond to your questions on the Q&A board in no time. And Mike, who is over there with you in Singapore, will also help facilitate any questions raised from the floor. So now we are ready to start the session formally with an opening remarks to be given by Dr. Cindy Cisneros Tiangco, who is the Director of Emerging Areas, Energy Sector Office of the ADB. As you know, Cindy has been instrumental in a lot of firsts. Hang on, I just need to show something on my screen if you bear with me for a second.
It's okay, Lit. We can see it. It's being flashed here now. Yeah.
Oh, all right. That's good. Right? Okay. Cindy has been instrumental in a lot of firsts in the energy sector of the ADB. She led the design of Uzbekistan's International Solar Energy Institute and its solar roadmap that led to gigawatt scale deployment in less than 10 years. She catalyzed ADB's first solar project in Afghanistan, conceptualized ADB's first energy sector financial intermediation project in Armenia, and introduced the renewable energy auction mechanism in Kazakhstan. Cindy also paved the way for the demonstration of new renewables such as floating solar PV through pilot projects in Azerbaijan and in the Kyrgyz Republic. As part of the FPV roadmap she advanced for 11 Pacific Island countries, She also developed the first nearshore marine FPV plus productive uses of energy projects in Kiribati and Tuvalu. She piloted joint procurement and regional procurement in ADB, embodying ADB's shift to new ways of working under the new operating model. You know, we are very happy to have Cindy here with us. And so may I introduce you to Cindy? Cindy, please take the floor.
Thank you. Thank you very much, Lynette, for the kind introduction. And thank you, Mike, for holding the fort over there. Hello, everyone. Nice to see you again.
Hello, Cindy.
Hi. Yeah, it's only been 3 days since we left, but I know most of you are probably tired already from all the week-long, presentations and discussions. But thank you for staying with us until the end. This ultimate, I guess, event as part of the series of events that we're having in Singapore, starting with the benchmarking workshop under the Pacific Power Association, which was, of course, organized under our technical assistance in the emerging areas team. Then we have AIX by ADB workshops as well and conference, where I had the opportunity to be in the panel to talk about AI and sustainability and how these all apply to the Pacific Island countries and also to our participants from South, Central, and West Asia. So welcome to this fourth of our series in a knowledge event series of the emerging areas energy sector. I guess I don't have to go through all the details that we did and also heard during the workshop for the benchmarking as well as for the AIX ADB. And of course, we are looking forward to the going live of the benchmarking dashboard, which will, of course, revolutionize the way you manage and perform your performance and manage your performance in the utilities using digitalization as well as big data. And of course, on the AIX, we talked about how AI can be used for sustainability and how we need to be sustainable in our use of AI in our operations. And I look forward to working with all of you again over the next few years to really develop, AI and sustainability solutions in your countries. So during the week, I think our team has been distributing our brochures for the initiatives that we have. Please do reach out to them, not only for more information about, Mike is going to be distributing more of this. And you can scan the QR code to look at other information or background that you might want to learn about the team and about ADB in general, what we're doing in your region and in your DMCs. So today's knowledge sharing series event will be focusing on marine renewable energy and blue economy, as Lida said. Of course, we know that marine renewable energy is a production of energy which makes use of marine resources or marine spaces, which is a step towards decarbonization and contribution to the growth of the blue economy. So the sustainable use of ocean resources for economic growth include livelihoods and jobs while preserving the health of ocean ecosystems is essentially what the blue economy is all about. We will be joined by a pool of international experts who will be sharing their practical experiences and their expertise, of course, from the field, and where we hope the DMCs, especially our archipelagic nations, big ocean states, small island developing states, and fragile and conflict-affected situations, will learn from these experiences and have a think of how and where these frontier technologies and nature-based solutions could be applicable in your own context. As the respective Asia and Pacific countries and the region as a whole, we aim to be forward-looking with the ways and means to improve resilience and future-proof the region from the impacts of climate change. So the emerging areas of the energy sector also share in this goal. So the team are open to working across sectors and across disciplines. We hope that this knowledge-sharing event, or this series, could contribute to propelling future conversations between the ADB and your respective governments. Down the line, we would be happy to be actively involved in your country's uptake of sustainable pathways and appropriate solutions. Thank you for staying with us for the rest of the afternoon. I wish you all a successful event and productive time of information sharing and knowledge exchange. Thank you, and welcome to the series. Thank you.
Thank you very much, Cindy, for your introduction. that sets the stage really well for today's presentations. We have the panel ready. But before that, I'd like to introduce to you Dr. Michael Abundo, who you know very well, is with you right now. He will be giving an overview of MRE and blue economy, and who will also be moderating the panel discussions, presentations and discussions later. Let me just
I think, Lid, it's
yes.
okay. They could see the information on the slide, and I'm happy to welcome them again to this webinar. So I could just take over from here. So you met me the past few days, right? So I've run a company called Ocean Pixel, and we focus a lot on blue economy development. This afternoon touches on one of my favorite sectors, which is obviously on marine renewable energy and how that could enable the blue economy. I've been active maybe the past, I would say, 15 years in this space, but only 10 years ago, the spin-off Ocean Pixel came to life out of Singapore's Energy Research Institute at NTU. Then now we're supporting the Asian Development Bank with all its developing member countries to look at emerging options. And so with the Pacific Islands and all archipelagic nations, anywhere where there's water that could be harnessed in terms of energy and other sectors, we are very interested to look at working with you guys. Okay, so maybe we shift to the presentation. I'll do a quick overview, and please, I encourage you to interrupt me at any point in time to ask questions right away before we go into the panel session per se, because I think this first part is a little bit of a close-knit session between me and you guys. Okay? Yeah? Perfect. So marine renewable energy and the blue economy, that's the session for this afternoon. You have my details there in case you want to reach out. And we have been looking at enabling sustainability through data intelligence. So the importance of data science, and AI was emphasized to you this past week, right? And in decision making and in other forms of technical advisory and other services, data and digital tools will be very important. And so we embarked on this journey 10 years ago for marine and blue economy sectors. And what we found out was there was a lack of data, one. There's lack of awareness that there are options that you could use in marine environments. And there was a lack of desire to go into blue economy development just because a lot of folks were not that knowledgeable in this space. So today I'd like to highlight a couple of important slides, and this is one of them. Cindy already mentioned marine renewable energy being renewable energy production, which makes use of marine resources or marine space. So many people, and today you will be an expert somewhat, say, oh, ocean renewable energy equals marine renewable energy. Not so. So ocean renewable energy is a subset of marine renewable energy. So we say marine renewables includes offshore wind, marine floating solar, marine biomass, tidal energy, thermal energy, wave energy, salinity gradient energy, even tidal range. All of these are marine renewable energy. But when someone says to you, ocean renewable energy, that's only these 5 resources: currents, thermal gradients, waves, salinity gradients, and tides. Let's look at each one of them in a little bit of detail. So I think the easiest one is solar, right? So you put solar panels on the surface of the water, and it's already considered marine renewable energy, even though it's harnessing energy from the sun and not necessarily energy from the ocean. But it is in marine space, so they call it marine renewable energy. Offshore wind, also easy to understand because it's just wind technology put in marine spaces. So it's part of marine renewable energy. Marine biomass, yes, you can harvest some marine biomass and probably process it to become, biofuel or other things. But there's still a lot of technology development or some form of pre-processing required because you need it to be dry, right? For ocean renewables, So let's do this one by one. Currents. There are different types of currents. Ocean currents typically is unidirectional. Tidal currents, which are not one directional, they change with the tide. Sometimes it goes one way, sometimes it goes the other way, depending on the Earth, Sun, and Moon gravitational ecosystem or relationships, right? So these currents are basically flow of water. Thermal gradients, meaning the difference in temperature. Why? At the surface of the sea, it's hot, probably 25, 30 degrees, sometimes 35 degrees, right? Celsius. But if you go below, slowly the temperature will drop. If you go 800 meters below, probably the temperature difference from the top to that position will be more than 20 degrees, which is enough to boil certain types of material or fluids, right? So thermal gradient, if you have hot and then cold, that difference can then power a almost like a pump, right? And so there's a mechanical system there that can then generate energy through the conversion of electromechanical systems. Then wave energy harnesses energy from the disturbance of the water, typically from the surface. So if you don't know what waves are, there's a formal definition, but you could have a body of water and you just blow on top of it like that, and you see that there will be ripples. This disturbance on a large scale, caused by maybe winds from somewhere, causes waves, and the waves, you will have waves in the Pacific for sure, and you can harness that mechanical movement. This hydrokinetic energy is possible to harness as well. Salinity gradient, yes, even the difference in the saltiness of the water can be harnessed to produce energy. Where would you have differences like that? Salty water, ocean. Not so salty water, maybe from the rivers or the estuaries, right? So sometimes there will be areas which are very, very salty and areas which are not so salty. In Singapore, they use this technology because they have desalination plants. So the desalination plants, they produce fresh water, but then they need, as a byproduct, it also produces very salty water brine. And this needs to be re-injected back into the sea. But during the process, you can also extract a little bit of energy recovery from the process, right? So seawater compared to this very salty brine, you can have a difference of salinity, which they can harness using membranes. So then the last resource is tides. So these 5 different resources, so the tides being the last of them, high tide and low tide, will have the same principle of capturing the energy as traditional hydropower plants, where you trap the water. So you have high tide and low tide changing action, right? If you had like a large dam that basically trapped the water, when it goes high tide, you trap it, and then this goes down when low tide happens, then you can release the water. Vice versa, you can also do the same. When you go up, then you can release impound and inside. However, this last mode of ocean renewable energy, this last resource, has very high environmental impact. So people are not looking at that as proactively anymore, not with the tidal range, the current tidal range technology. So yeah, so far we are clear here. Any questions? Yes, go ahead. You can harness seaweed. You can harness seagrass. Oh, not seagrass. Seagrass is important for carbon. So maybe seaweed and kelp. Yeah. Any other questions? Yes. So far clear? Yes. So now you are much better than people who say, I want to harness tidal wave energy. You don't want to harness tsunamis, right? You don't really. You don't want to wish for tsunamis. So please correct them sometimes. The tidal energy, wave energy are 2 separate things. Please don't pray for tidal wave energy. Okay. Any more? So far, okay? Yes. I mean, biomass is proven.
Yeah, biomass is proven.
But that means
But
you
marine-
extract the biomass from the marine environment. Then you need to do pre-processing, like drying and all of that. Then you can put it into the biomass technology. So it's already, it's more the economic side, How much are you willing?
The biomass plant is not on the marine, eh?
So the
So
biomass
like-
plant can be onshore?
Yeah.
And then you extract the feedstock from the marine biomass. So typically these are like um, uh, marine biomass debris, you know. But if you're growing it, it's okay. But if there's a surplus, that's even better. Yeah. Okay, shall we move on? So far, okay? Yeah. I only wanted a few minutes, but it's important to know that all these technologies have a range of what we call technology readiness levels. You know, not all of them are commercially mature. A lot of them are still in the middle stage. This is a technology readiness level scale 1 to 9, which was first used by NASA. 1 being very early stage, basic principles. 9 being technology already mature, commercially available, you know, system ready, basically operational. Okay? Everywhere in between is a spectrum. So there are offshore wind. You say, but offshore wind is already commercially mature. Yes, but still there are R&D, research and development still happening. So never will a technology really just be mature, but it is a range. No? So certain types of like floating offshore wind, it's not yet at 9. It may be somewhere between 5, 6, 7. But then they're going to mature it, right? So here is sort of the average of some of the technologies. Marine floating solar has reached pre-commercial stage. Actually, is a little bit already commercial. Tidal range, commercial. Offshore wind, commercial. Tidal stream, pre-commercial. Wave energy converters, sort of between 6 and 7 on average, right? OTEC, they say it's 6, but in India, they mentioned that they've been using OTEC type technology for their water production since 18 years ago. So which means it's probably pre-commercial from that perspective, right? Salinity gradient, they say it's early, but now it's moved probably now to 6 or 7. So this TRL level is important, and you might want to take note of typical plant capacity factors. So you're all power people, and so that probably is important for you guys. Depending on where you are, it will change. And so the answer is not one type of renewable energy. The answer is a combination of options. So solar plus wind is probably a good hybrid for countries with good solar and good wind, right? So yes, question? No? Marine map developed for renewable energy resources? Ah, very good question. I love that. So I'll show you one for the Pacific in terms of wave or wind, but an atlas for marine renewable energy resources, that's something that globally people have tried to do for um, uh, marine solar. It's easy to do, right? Wind, also there's a global atlas for wind already, so easy for you to access that. Wave will be a function of where strong winds are. So you could basically do a correlation. Um, Thermal gradients, not as high resolution as we want it to be. Per country probably knows, and you need to know the water depths, right? So normally you need to understand your bathymetry. Currents, there are global models, but you probably know where the strong currents are. So in answer to your question, there are some maps, but not all maps are available, and most of these maps need to be validated in terms of measurement. Yes. Yes. So there are costs associated with it. We can talk some more, but it depends on scale, right? So a 1 megawatt power plant will be different in terms of pricing as compared to 10 megawatt and 100 megawatt. But there are, yeah. So we could share that with you as well. So I'm gonna move on. The map question here. This is sort of where wave energy is in the Pacific Islands as example. Yeah, so you can see moderate wave energy to high wave energy in most of the Pacific, right? And this is an annual thing. So the resource map is done in terms of kilowatt per meter of wave front, right? So you can install a lot. Now, these types of marine renewable energy are not only used for electricity, the grid for electricity. A lot of the countries that are island and island cluster in nature have started looking at marine renewables for productive uses. So the Orkney Islands, they're in the UK, north of Scotland. They started the European Marine Energy Center because they had good uh, wave and tidal energy resource, tidal stream energy resource. And since 2013, they have been 100% renewable energy powered. So it is possible to aspire for high RE penetration. And with that, they have aspirations to export back to the main grid. They also have been using the RE for productive uses, and they have a surf and turf project, they call it, for producing green hydrogen. Green hydrogen for what? For fleet of cars, for boats, and if you see a picture there, even a hybrid hydrogen electric plane. Cool, right? So the Maldives is aspiring to do the same. They've started looking at electrifying or do renewables for their islands, solar first, and then solar plus wind. And now they're looking at marine renewables to be part of their mix. They obviously will not have large megawatts. So we need small but hybrid systems for islands. And the productive uses of energy, something closer to home in the Philippines. We have use for renewable energy into seaweed production and in water production and in other productive uses of energy. In Singapore, there is this hybrid microgrid test bedding area. Um, yeah. And of course, there's solar, there's wind, and there's an NG logo right there. I think you spotted it, right? So microgrids are obviously at the heart of island electrification and island power systems, right? So it's important to note that energy is not just for distribution of electricity into households and businesses and government agencies. You could do a lot more productive uses and therefore boost economic impact for the country if you planned it in an integrated manner. So marine floating solar, then, all these things that are sustainable development linked could actually be integrated into projects. The other term that we wanted to maybe have a simple definition around is the blue economy. So now we know what marine renewable energy is. The blue economy was defined by the World Bank as sustainable use of ocean resources, including energy resources, for economic growth, improved livelihoods, and jobs while preserving the health of ocean ecosystems. So this is important because now developmental organizations are looking at multi-sector type projects. So not only power and energy, one sector, but can we combine power with water, power with environment, power, water, environment? What about power and ICT, power and transport, power, ICT, and transport? So the more sectors there are, the better it is in terms of vulnerability, addressing of vulnerabilities. So we need to start talking beyond our power colleagues about the possibility of developmental impact, and the blue economy presents a huge potential in terms of economic impact. Globally, they estimate 3 to 6 trillion US dollars in terms of total addressable market. What we estimated in Southeast Asia, it's already more than 6 trillion, just Southeast Asia. And in the Philippines, just one country in Southeast Asia is already more than 1 trillion in terms of market. Why is that? Because there are many sectors in the blue economy. Energy will just be one of them. Blue carbon is another one. Fisheries, aquaculture, tourism, ecosystem services, and many more. So it's not surprising that the ADB wants to put in a lot of sort of investment and financing into the development of healthy oceans and the blue economy. And you can see one of the circles here, just below there, marine renewable energy. It should enable the blue economy. So you have projects now headed by the Emerging Areas team or developed by Cindy's team to look at marine floating solar combined with other productive uses of energy such as regeneration of reefs, electrification of boats, having charging stations attached to this marine floating solar so that you're charging also electric vehicles. So you need not just plug into the grid. You can look at other productive uses of the energy. So this is one project we did in the Philippines. There's a charging station. There's an island microgrid with a resort that has desalination systems. But to couple it with electric boats would be one way to diversify also income. If you're a utilities body, you can look at, hey, why not I also have income in rental of services of boats. This particular boat is used in 3 ways. For fisher folk, they use it from 4 a.m. to 7 a.m. For tourists, from 8 a.m. to 3 p.m. And inter-island ferry transport from 4 p.m. to 6 p.m. The more you use electric boats, the faster the return. Why? Because you offset the diesel. So which means that you save more diesel the more that you use it. right? So the faster the return. We also need to use technologies when we look at the blue economy and marine renewable energy, not only in surveying and understanding, but also in looking at the environmental impact. So biodiversity, you now have video and AI tools, to classify and quantify how much is the growth of these biodiversity areas. So when you put floating solar projects, for instance, or other installations, it's not necessarily bad for the environment. Sometimes you see a lot of marine growth that is enhanced because of the presence of these structures. So you need to study that as well. So I'm going to play a couple of videos. If you could click the two videos, please. Yeah. One here on the left looks at tidal energy in Singapore demonstrated. Small 70 kilowatt machine combined with a small sort of 1 kilowatt solar. But yeah, on the right, if you could click the video on the right, it's okay. Okay. It's a chance to look at sort of blue economy. And I would like just to highlight, how complex it is to look at an energy project, floating tidal turbine platform over here with diesel genset. You can look at it as a floating power barge, a renewable energy power barge if you had all renewables, but you could do hybrid microgrid as a floating system too. And local boat building, right? Look at on the right, things that you could do in terms of environmental work, aquaculture work, ecotourism work. So I'm trying to see here a contrast of the technologies and the interventions that could be done. Yeah, it may seem that they are a little bit different, true, but they all use the same common space, the marine environment, right? So if we look at things moving forward, I challenge us to look at blue economy development using a holistic approach. And that means that we ultimately need to look at streamlining these multi or cross-sectoral interventions with an integrated approach. So I probably will stop here. We can do listen more to the panel a little bit, but if you had questions, please ask. No, so far okay. Yes, yes.
Just had a quick question. There was on the Orkney slide, it was talking about 100%.
Renewables. Yeah.
But the figure was 107%.
Yes.
How does that work?
So basically, they produce more than what they need in terms
So
of
they
demand.
export?
So they don't have export yet because there's no cable. So what do they use it for? Either it doesn't go back to the grid, or they use it to power some productive uses, right? So yeah. So now they're at 130%. 130%. So they can really play around with the. Okay. So some ideas for pilots: combine the marine renewable energy with transport, ice, aquaculture, ports, water, reef, and other business models. Right? But we're not gonna do that right away. Tomorrow, we need to start with one project, then maybe later on replicate it, then later on scale it. But at various scales, we need to think with the blue economy, with a blue mindset, so to speak. So we may start off with various efforts now. We do want to reach the regional ecosystem that's enriched. Maybe the whole of the Pacific gets interconnected with blue economy initiatives. We now need a hub stage. So the PPA is a perfect vehicle for a hub stage. PPA could start talking to, maybe there is I don't know, an analog water association or aquaculture association. Can we start talking amongst associations to start looking at joint economic development? And so with that, I end that blue assets do exist. We have to have a progressive development approach towards a blue economy and having a blue mindset. So that's for the first part of the afternoon. And now we have a few of our speakers online. May I call on our first speaker? If you have questions now, I'm gonna sort of ask you guys to maybe I can go around and get some of your questions so that during the moderation, I could basically ask the panel as well. Okay? So can we move to the Zoom? Yeah. All right. So
Right. I hope you can hear me. My name is James
Yes.
Sutherland. I'm from a company called HR Wallingford in England, and we're a specialist civil engineering consultancy. And I've been working in offshore wind now for over 20 years. So if I could.
James, yeah, feel free to share your slides, James. Yeah.
Yeah.
So Dr. James Sutherland will speak to us about offshore wind energy. He's the technical director and team leader for the coastal and seabed processes teams within the Coast and Oceans group of HR Wallingford. Thank you for joining us today, James. Yeah, the floor is yours.
Thank you. So I'm talking about offshore wind energy, and this slide shows some of the offshore wind farms that we've worked on over the last 20 years. We've added a couple recently. So I'm going to start with a little video. Let me know if you can hear the sound.
You can't hear the sound of the video, James.
Okay.
Yeah.
So this is just giving you an indication of the sort of scale of offshore wind farms. So these are quite large in size. So we're looking at about 70 meters for fixed offshore wind. Beyond that, we have to move to floating offshore wind. So here we have the continental shelf in Britain, where it's relatively shallow, so we have a lot of fixed offshore wind, sometimes quite close inshore. This is a brief example of floating offshore wind, can be deployed in hundreds of meters of water depth. I'm actually going to stop that there. We can't hear the video because it's too long anyway. Sorry. So if we look at annual installations of wind in megawatts from 2006, there's been a fairly steady increase through to 2022. There was a big jump in 2021 due to a change in feed-in tariffs in China. And China is the biggest player. Europe in blue, the second biggest, and the rest of the world is starting to develop offshore wind. So if we look at projected annual installations, we'll look at compound annual growth rates, perhaps of 30% initially, maybe slowing down to 12% later on. But it's projected that Asia Pacific and Asia Pacific, excluding China, is going to take a bigger and bigger share of the marine offshore wind. So if we look in particular at the Asia Pacific area, China is the dominant partner in the area, but Taiwan is already building a number of wind farms. South Korea, Japan, Vietnam, India all have plans to enter the market or are entering the market, as is Australia. So it's a growth area economically. Floating offshore wind is a less well-established technology. There are issues that are being worked out. So it's been doing fixed offshore wind for over 20 years. Floating offshore wind is just coming on stream with some demonstration projects. And again, there are a large number of countries looking to get involved in that, including South Korea, Japan, China, Taiwan. So we've done a study of floating offshore wind. Here are some examples of the infrastructure used. And one of these floating devices can be 100 meters across by 100 meters, 100 meters in all directions, so it's triangular. And from the base of the structure to the top of the blades can be 300 meters. So these are huge structures. And our resource constraints. This is just in Europe. We're looking at materials, fabrication facilities, assembly and integration is an issue, and developing new equipment, including means of mooring it and means getting the power off, because power cable failure is a relatively big issue for the sector. So there are already relevant plans in the area, including ASEAN's Plan of Action for Energy Cooperation, Vietnam's Power Development Plan, the Just Energy Transition Partnership, and SCM power grid. Application to island states, small island states, some of them are not connected to a national grid, and therefore to have a local power supply is very good. Often they often work best as part of an integrated network. And if you're in a small island state, the transmission network to other states and islands may be expensive. Many small and developing states have a narrow continental shelf, so there's limited space of fixed offshore wind, meaning floating offshore wind is maybe in the long term a more viable alternative. At the moment, it's more expensive and less mature technology. What are the requirements for success? Well, you need a sufficient area of seabed. So you need perhaps marine spatial planning because your use may conflict with that of other users. Fishermen, shipping, defense even, mineral extraction. So some countries are developing specific marine spatial plans for offshore wind and these other uses. Efficient permitting, a one-stop shop for getting permits, because you often need permits from many different government departments, and it can be difficult to know where to go for all of them. And it can be time-consuming. It can take up to 9 years to get all the permits you need for an offshore wind farm, by which time the technology has moved on. The scheme you have a permit for is no longer the scheme that you want to build, but it's the only scheme that you have a permit for, so you have to build it. You need to create social and economic value. This can be in terms of local content, to provide local value to the community that's been affected. You can provide skilled jobs in green energy. There can be permanent jobs in terms of operations and maintenance, and there can be jobs in terms of fabrication and deployment. There can also be environmental benefits as a byproduct of these schemes. So that's a good way of getting buy-in from the local community. You need grid connections because you're generating power in a new place. You need them between wind farms, to the shore, and to the consumer. And for the government or some big network to provide the grid connections is vital, because some offshore wind farms have been permitted, they're ready to be built, but if there isn't a grid connection, they have to be delayed. Construction can be delayed by lack of connection. So we have problems in supply chains, which are gearing up worldwide. We have supply chain issues for wind turbine installation vessels, cable lay vessels. Simple things like gearboxes and high voltage switches can be in short supply because there's a big demand for marine renewables. And ports. Ports are going to have to be adapted, particularly for floating wind, to cope with much bigger, wider vessels. Channels are going to have to be deeper and wider. Navigation issues are different when you're towing a large floating offshore wind installation. Right. So thank you very much for your time. I've had my 8 minutes. There are my contact details. Do we do questions later on?
Thank you so much, James. Yeah. Yeah. If you had any questions, please feel free. I will go around and ask you guys later as well. We could proceed to maybe we give James a round of applause, please. Yes. Thank you so much. And I think I have here a way to, yeah, okay, here we go. We'll welcome the next panelist. We have Dr. Cameron McNatt, who's the Managing Director of Motion Energy Limited. Cameron loves the ocean, cool technology, and working with others to try and make the world a slightly better place. He is the Managing Director and co-founder of Motion Energy, which develops novel ocean energy technologies, specifically right now for the oil and gas sector, but they focus on wave energy. So without further ado, we have Cameron. Say, we can see you now.
Hi,
Yeah,
hi,
right.
Mike. Hi, everybody. You guys can hear me okay?
Yep, we can.
Great. Well, good afternoon. It's a pleasure to be speaking to you today from halfway around the world. Let's see.
Yep. Please feel free to share your screen, Cameron. Yeah.
Yeah.
While you're doing that, we could, yeah. Okay. There you go.
Okay. And okay. So just a quick overview of what I'm going to be talking about today is I'll be presenting just one slide. I mean, I think Mike actually gave a really good background on wave energy, but just one slide on wave energy, so we're kind of on the same page. I'm going to be talking mostly, well, I'll be talking then kind of about Motion's view on wave energy and our route to market. And then we have, done some very early projects around a couple of islands. And so I was just going to share our experience there in the context of marine energy, wave energy for islands. So what is wave energy? Waves are created when wind blows over water. There's more or less two kinds of waves. There's sort of locally wind-generated waves. So these are waves that you might have in your harbor or near shore due to the wind that's blowing on you right now. And then there's swell, which more or less are waves that are created somewhere else. So these are created by big storms that happen out in the ocean. And waves are actually capable of traveling very, very far without losing energy to friction. And so they can arrive at shores when you don't have any local wind. And those types of waves are actually quite important because it means that you can get energy from waves when you don't have wind and potentially when you don't have the sun as well. Then, so waves are moving up and down and back and forth, and that motion needs to be converted into a mechanical motion and then to an electrical power. So I think one of the challenges with wave energy is that up and down, back and forth reciprocating motion. And one of the challenges with the industry is that there's so many different ways to do that. It's not the sort of standard underwater turbine that spins in a single direction. So this is an oscillating water column. So the water is pushing air up and down, back and forth through a turbine. So I'll just show a couple to get the idea. This is a heaving buoy that's attached to the seabed. So again, waves are pushing this up and down. There's a kind of linear generator there that's generating electricity. And then this one is this is basically our motions kind of device. So we call it a hinge draft. It's often called an attenuator. Basically, waves pass by and cause a flexing about a hinge, and then that drives a generator and produces electricity. This is how I really like to frame motion strategy. Developing this technology is very challenging. You've got to reach a competitive cost of energy. The ocean is a really harsh environment, and it can potentially be very expensive to do it. And so at Motion, we're following the approach that we believe was set by Denmark in becoming leaders in wind power. So a very small country, but leads the world in wind. And that's because, in our view, companies like Vestas and the company that is now Siemens Gamesa, they didn't start with this. They didn't start with the big offshore wind farms. They started small with small-scale distributed projects selling individual turbines to communities and to farmers. They learned by doing, and there was policy and R&D that helped scale that up to the sort of offshore wind powerhouse that it is today. And so at Motion, hang on a second. At Motion, we are also starting small. So our first product is called Blue Star. It's primarily wave energy, but we're also integrating solar into that. We're integrating battery storage into that. We're integrating a wireless communications link. And what it's doing is creating an offshore renewable microgrid for supplying power and communications. So the wave energy part of it is a hinge draft. You have, again, two hulls connected by a hinge. Waves cause a back and forth rotation about that hinge that drives a generator and produces electricity. Now, our IP, our innovation, is in the shape of the machine. So we've developed these novel hull shapes that are characterized by these big plates or scoops or shovels on the front and the back. And basically what they do is cause the machine to move more in the waves. The more it moves in the waves, the more power it generates. And so you might say, well, what are you doing with this funny little machine? So as Mike said, incidentally, where we've found the most market traction and kind of the best value proposition is in decarbonizing oil and gas and carbon capture and sequestration. So what does that look like? So in that market, what we're doing is providing power and a communications link to subsea equipment. So this is equipment that sits on the seabed. So it's either extracting hydrocarbons or it's injecting CO2 into depleted reservoirs. That's the carbon capture and sequestration part of it. And so what we are is decentralized renewable power generation. So we're providing power where it's needed rather than running a cable across the seabed to get power there. So there's a couple of value propositions. Basically, we save customers money and we save them CO2. The technology is TRL 8 on the 1 to 9 scale. We've had 18 months of testing over 2 campaigns. So we start small. Oh, sorry. So here's some video. So this is in Orkney, Scotland. We saw some really big seas as part of our trials there, and that was very exciting. So great to get these kind of data points and prove the technology is robust and reliable. So we start small and we go big. So Blue Horizon is our large-scale ocean energy solution. We see applications like, and again, we're combining wave, solar, energy storage if needed, to create a microgrid to ensure that we can consistently deliver power to projects. We see applications like power for the blue economy. So these are things like decarbonizing ports, power for aquaculture, and then kind of future things like subsea data centers and direct ocean CO2 capture. And then power for islands. So I think you all, this statistic I got from IRENA and is from 2023, but islands are really only fractionally decarbonized. We know that they need more low carbon solutions. And we know from our engagement with these projects that yes, wind and solar are going to be appropriate for some projects, but they're not going to meet all their needs. Sometimes there's not the land area. Sometimes there's not the infrastructure to land, wind turbine nacelles and towers and blades and then get them up onto these really remote places. Whereas our system, the concept is that it can just be towed to where it's needed and anchored offshore, and then you're just running a cable back. So potentially that can be simpler than other onshore renewable projects. And we're looking at sort of early stage levelized cost of energies. Sorry, this is in Great British pounds, but of around 280 pounds per megawatt hour, but that's very project specific. And then in the slightly longer term, we see combining wave energy alongside offshore wind in larger scale offshore energy parks. But here I want to sort of share a little bit more information about our experience with islands. And just to be clear, we're still very early in this kind of engagement. So one of the projects we looked at is called Isla Santa Maria in Chile. So it's a small, very, very disconnected island off the coast of Chile of around 2,000 inhabitants. They have a diesel power station. The energy prices are highly volatile. So as are the prices of fossil fuel, of course. So they sort of ranged from 635 euros a megawatt hour up to 1,200 euros a megawatt hour. They don't need a terribly large amount of power. So we're talking about 942 megawatt hours per year, but that is estimated to double by 2030. And for some reason, and this honestly wasn't really quite clear to us, they've never really been able to install solar or wind projects on the island. What we heard was that there was concerns about actually the sort of the solidity of the land. There was, I think it was due to an earthquake, the actual island moved a little bit. So I think there was concerns about that for wind. When we looked at sort of access to the place, it was about 36 kilometers from the nearest major harbor. And so we worked in this project, we designed a project on paper. So we worked with a local partner called MERIC, that's a Chilean body focused on marine energy. And we sort of designed a project on paper that would be a 1 megawatt wave energy plant. And we estimated the levelized cost of energy for that would be about 595 euros a megawatt hour, which would be comparable to the existing power generation prices. We also visited the island. So we went with reps from MERIC, with also local government and other stakeholders. We had the opportunity to go around to a couple of community halls and meet the residents and present to the residents. And some of the concerns we heard from them were about interference with fishing. So fishing is probably their biggest industry, and they were very concerned about how the technology would potentially interfere with that. And from our view, it would be very minimal. The technology would be in one location; they'd still have plenty of fishing grounds. The other thing relates to what I said about the solar and wind projects. So the community had been approached at various times by project developers sort of talking about doing things, but nothing ever happened. And actually there was a real sense of frustration. And I have to admit, we were almost doing the same thing. We were there speaking to them, but we were not in a position to deliver the technology straight away. And so that's another challenge, is that we don't currently have a technology of the appropriate scale that is designed for this market. Some other challenges we found when looking at this were sort of the access to infrastructure, the distance to the port, who's going to maintain this equipment. This coast is very ecologically rich, so there are very concerns about the ecological impacts and then the marine growth on the machines. And then, of course, you have to think about, how are you going to fund these projects? So lots of challenges. The next project, I know I'm using a lot of time, but I'll run through this very quickly. Was a project called Uquat in Canada, and this was with a First Nations community called the Muchalat, and they have this territory, a historical village called Uquat, where people don't live year-round, but they want to reestablish it as somewhere where people can go, where tourists can go. There's no grid connection, and the First Nation said, we want wave energy. And so they worked with a project developer as well as the University of Victoria to try to source that project. So we did a feasibility study for them. We estimated power capture from wind and solar, survivability. We looked at all the sort of engineering things. And for us, the challenges again were, the first of a kind costs are still going to be quite high. And again, the technology that we would want to deliver, we haven't yet built it and tested it. So in conclusion, from our perspective, there is a strong interest and a strong need from islands and communities for wave power, but the technologies needed for these projects are not quite ready for the market. You can't just go and procure a proven wave energy converter for these kinds of opportunities. And so in our view, the technology needs to be co-designed with islands in mind, so working with these communities, and you can do that through case studies, and then it needs to be proven in early demonstration projects. So thank you very much. I'll stop there.
Thank you very much, Cameron. A round of applause for Cameron. Speak more. On to our next panelist. Can we just check if Andrew's there online? Yeah, so Andrew Aviard is the business development lead for energy in the University of Edinburgh, and has commercial engagements as well, facilitating relationships between the university and the industry to enable successful delivery of innovative energy projects and skills training, which are needed to support the just transition. So without further ado, here is Andrew to speak about tidal energy.
Thank you. As I should say, yeah, I work for the University of Edinburgh, but I previously worked within tidal energy, and so that's why I'm here today. I am here to give an overview of the sector within tidal energy, talk a bit about the different technologies, the resource, and what we are moving forward with. So let me just share my screen. Hopefully that's sharing. So yeah, today I'm going to talk a bit about the resource, a bit about the technology, some of the future challenges and opportunities, and a bit of why we are important in the university. So when looking at tidal energy, we're starting with the resource. Now, there's different ways of measuring the resource. What I've put here is the actual sort of practical level of resource. So what we think we can actually achieve. So there's 100 terawatt hours a year we think we could achieve with tidal energy by about 2050. And that's out of a 300 gigawatts of energy projects by 2050 we think will develop. Now, that's across a different scale of types of projects. So we're looking at some high capacity sites such as Penn and Firth and Befunday, but there's many numerous smaller community scale projects. So we know there's a vast amount of resource. But when we're talking about tidal energy, what are we talking about? Well, imagine a wind farm, but under the water where the currents power the turbines to create electricity. So in the future, I think we're going to have projects that look a bit like this. But we've got different types of tidal energy. We've got tidal energy that is seabed mounted, and we've also got floating tidal. So we've got many different kinds of devices that look like that. Now in Scotland, we've been the forefront of this technology for many years. Back in 2016, Nova Innovation developed the world's first tidal array, installing 300 kilowatt machines in Shetland. Then Orbital Marine Power have developed the most powerful tidal turbine, 2 megawatts, and then we have Maygen, who have developed the largest tidal array in the world, which is a 6 megawatt array in the Penn and Firth. So, but what are the benefits? Well, we're looking at up to 300 gigawatts of ocean energy installed by 2050. Potentially that equates to 680,000 jobs, looking at 340 billion pounds of GVA added, and over 500 million tons of reduction in carbon emissions if we're looking at that megawatt of installed capacities. But where are we and where are we going? So by 2025, by this year, we had 12 megawatts of tidal energy installed, mostly in Scotland, and 12 devices. And as I say, those have been installed and delivering thousands of hours since 2016. But over the last couple of years, we have seen the developers we talked about, so Maygen, Nova, and others, applying for UK government CFD, so subsidies for generating electricity. And so we now have over 120 megawatts, which are about 94 devices that have received subsidies from the UK government. So these are going to be commercial scale projects installed in UK waters. And as you can see, the prediction is that this is just a start, and we will see this ramp up of installed capacity of tidal energy over the next 20 years. And that all helps us, you know. This is almost a pre-commercial edging into commercial technology that has seen its pathway of cost reduction start to increase from the development of bespoke demonstrator models into commercial models that is now replicable. And so we've seen a clear cost reduction pathway that's started to develop and can actually deliver the scale we're talking about at a comparable cost prices. Now, we know that in different locations, in say rural coastal communities, that price index will be higher. And we also know that at scale utility, that price will be lower. So depending on the scenario, you need the device, and depending on what the situation is, that price point might be different. But both will be economically viable in those situations. But there are many challenges here. We're still at this pre-commercial stage where innovation is going to need to continue to develop as we get more devices in the market and look at more different scenarios. So the challenges around manufacturing, as you said, we have developed bespoke commercial demonstration devices, but we need to be able to develop those in scale and number volume. So we've not got 12 in the market. We do have 200, 300. And with that comes operationability, making sure they operate successfully in fleets over periods of years. I've just been at Ocean Energy Europe up here in Scotland, which is a showcase of the industry, and looking to getting to a point where the maintenance of these devices are almost every 6-7 years. So over a 15-year life period, you're only bringing some of those devices out of the ocean to maintain them once in that period. So ensuring that reliability, ensuring that we don't have to go back, we have no problems, and that helps with the affordability. But as we know with every technology, there's always that innovation cycle. So once we have something in the water, we're looking at what's next. How can we improve it? How can we make it more powerful, more reliable, bigger yields? So for us in the UK, there's a real opportunity to develop manufacturing bases, looking to export these things globally. We've seen that development in the UK. We're now looking at a pathway of 200 megawatts. But how can we start exporting those to other locations around the world? Then there's the development of this O&M. Yes, okay, we have thousands of hours. We know how to lift the 2 or 3 devices we have out of the water, change them. But how can we improve on that O&M? These devices and these developments we've had have been in islands around Scotland, so Shetland and Orkney. So we know how they work in grid constrained islands, providing base power in many cases. The picture on the bottom right is up in Shetland, where Nova are providing a baseload power, but also EV energy. So we're already doing some of these innovations, but how can we do that on other islands around the world? How can we provide the different benefits that tidal energy provides? So Scotland is currently the home, really, of ocean energy. We're building on the pioneers from 50 years ago to develop this world-leading energy, and when the commercialization of this is stuff. We have world-class research and world-class commercialization infrastructure, including the various universities such as Edinburgh. We have offshore renewable energy catapult, which is pushing that research into the ocean, and then EMEC up in Orkney, where we test a lot of these devices. We have this growing skills base and teaching capacity, and are already starting to see some of that technology exported across the world. At the university in Edinburgh, we helped develop Salter's Duck, which was really the starting point of this 50 years ago. And we've been going through and supporting devices and developers all the way through from Polaris in the 90s to the current range of developers we have now. But we still need future research. So we're still looking at technical innovation. We're still looking at how we can continue to develop some of these designs and as we go forward. As I said, we have single devices or up to 3 or 4 devices in the water. Nova have 6, Major have 3. But the next phase is multiple, 20, 30, 40 in some cases of tidal devices in the water. But what is the impact? What's the best array layout to make that work? So that's really important. So to understand that, we need to really develop our knowledge of the ocean, the digital twin, and understand what the currents are, what blockages may be, what the impact on the environment is. So there's all that sort of understanding of the ocean. And then the next phase is that commercial advice. What is the best way to develop these? And then there's policy advice. What is the best way for governments to incentivize some of these? At the university, we have multiple facilities to try and help develop this. This is FlowWave. This is our ocean test tank, so we can replicate ocean states around Scotland and other places around the world. With a bi-directional wave and current facility, which enables us to test tidal, wave, offshore wind, various devices to enable commercial developers to really hone and develop their innovations. Here you can see some of the tidal energy devices that are at this pre-commercial stage, all of whom have tested in our tank. We also have FastBlade, which is a tidal blade fatigue test center. Because these devices haven't been in the water for 15, 20 years yet, what we're looking to do is test tidal blades so we ensure their robustness. We ensure that they are designed appropriately for their life cycles. We talked a bit about digital twins. We have Edinburgh Parallel Computing Centre, which has one of the UK supercomputers, looking at how we can ensure that we're modelling these things properly. Some of these runs are taking, multiple cores, weeks, do a month's run of some of these proposed tidal arrays to understand what the flow and what the yield might be. I really like this quote. We recognise not a lot of you are going to have wave or tidal research departments in your companies, but we're here to try and help pass that information on and ensure that you can gain all the knowledge you need when you're looking at these sort of projects. And we've got a range of ways we can help you. So please do contact us if that would be helpful. So I'm going to stop sharing there and leave you.
Thank you so much, Andrew. Yeah, round of applause to you. We are halfway through. We have a couple more speakers before our Q&A. Later, Albert will be distributing some papers for you to write down some questions. You feel free to do that. For our next speaker, we have the head of policy and innovation group from the University of Edinburgh to speak to us about policy support mechanisms for ocean energy systems. He has been recently awarded the V. Maris Award, Power of the Sea Award, by an industry award from Ocean Energy Europe, no other than Professor Henry Jeffrey. Welcome, Professor Henry.
Thank you very much, Michael, for that introduction. And can I just check that you can see my slides and hear me before I start? So
that's right. We could see you, we could hear you, we could see your slides. Everything's okay. Yes.
Great. Okay. Well, nice to see you again, Michael. Thank you very much to the Asian Development Bank for the opportunity to speak to you today. Michael, you've given a very good overview of the ocean energy sector. I think we've had very good examples of wind and from Michael, and of wave from Cameron, and just heard about tidal from Andrew. What I'd like to do then is take a little step back from that and look at saying, okay, we've got these technologies, but what is the international opportunity for these technologies? And although, as you said, Michael, I lead the Policy and Innovation Group at the University of Edinburgh, I'd like to speak to you with one of my other hats on today. It's where I represent the UK government within the International Energy Agency's group for ocean energy, which is IEA-OES, International Energy for Ocean Energy Systems. And I'd like to speak to you about a piece of work that they've done, looking at the international opportunity, the international prize, as well as the policy and finance requirements for this sector. So where this work came from was midway through last year, the Central International Energy Agency produced their net zero roadmap for all the different types of technologies that would be required in order to meet our net zero target. And one of the statistics that was in there was that around 30% of the technologies that would be required to meet our net zero target do not yet exist. They're still emerging technologies. And the ocean energy sector is some of those technologies. So the IEA group for ocean energy, IEA-OES, then produced their complementary roadmap for the ocean energy requirements so that we could see what the enabling factors were in order to make sure that ocean energy played its role in as part of that overall net zero journey for the global international community. And that's what I'd like to talk you through this morning for me, or this afternoon for you guys. And as you said, Michael, at the beginning, very, very helpfully, that different sort of ocean technologies are at different parts of their innovation journey. And wave and tidal are at the highest of the TRLs there. And so this roadmap focuses on the requirements of the wave and tidal sector, albeit the IEA still look at OTEC, salinity gradient, tidal range. But this roadmap will be focusing on the wave and tidal sector. So the first thing the roadmap has done is outlined what the significant opportunities and benefits will be from the wave and tidal sector between now and 2050. They've indicated, and Andrew gave you a little bit of a preview of this, that there'd be around 300 gigawatts of ocean energy split between wave and tidal deployed by 2050. That would be the market share that they believe could be attained by the wave and tidal sector. That would, of course, come with benefits of manufacturing and operating and maintenance jobs, almost 700,000 direct jobs. Of course, this would come with very significant economic benefits. They've itemize this in terms of GVA, so around 340 billion in gross value added, or just economic benefit to the international community by 2050. And of course, very, very significant carbon savings by deploying the sustainable technology. And so that makes a very attractive picture of the benefits of this sector to countries around the world, including Asia Pacific and including island areas. But they've also been extremely clear, and it is the main message of the roadmap, that in order for this to happen, it isn't business as usual. It does require policy support and action in order to enable these benefits to happen. So the action areas that they have highlighted there are in 4 main areas. First of all, that we will require countries around the world to make sure that there are market pool mechanisms in place. Whether that be like a feed-in tariff or an auction, there needs to be a market pool mechanism led by an individual country level to make sure that these deployments happen. But in order to ensure that these deployments happen and we do come down in cost in the most efficient and effective way, there does need to be then technology push actions, as they describe, or innovation actions, innovation funding, to make sure that these technologies still become, as quickly as possible, more reliable, higher performing and lower cost, so that overall balance between the market pool mechanism and the innovation mechanism is as cost effective as possible. There will need to be investment in the overall infrastructure and supply chain. There will need to be refurbishment, repurposement, and potentially building of new ports and harbours for both the manufacture and the operation and maintenance of these devices. And there does need to be streamlining of the regulation and legislation for the deployment and consenting of these technologies. So what I'll do over the next sort of, 7 or 8 minutes is just give you an overview of some of the policy recommendations that they've highlighted in each of these areas. So I'll start and I'll bring together the market pool and the technology push, because these really go hand in hand, making sure that you've got a market deployment mechanism, a feed-in tariff or an auction or a contract for difference, as we have in the UK, but coupling it with an innovation program or a technology push program in order to make sure you're deploying that technology, but you're also innovating that technology at the same time. So that overall balance of those two technologies is as cost effective as possible, both with regard to the return and economic benefit and the cost that you will spend deploying the technology. And what they've done is they've done a piece of modelling at an international level. So these numbers are global numbers here. They're not numbers for any one particular country. And what they do is they look at whether you're innovating or reducing your costs at between 10, 12 or 15%. What is your learning rate that you're taking those technologies down with? And they've done it for the tidal stream sector that Andrew talked about. They've done it for the wave sector that Cameron talked around. But what to take away from this is that the finance mechanisms and finance requirements vary very, very significantly depending on how well you're innovating. And here you can see if you're innovating, reducing your costs at around 15%, then the overall price tag is around 130 billion for the market pool mechanisms. But if you reduce your innovation and your learning and you slow down that cost reduction, then there's almost a 5-fold increase in the finance requirements for this sector. So very clearly, treasuries around the world are much more interested in the 15% learning or 15% innovation rate than they are in the 10. And so making sure that as an international community, we make sure that we're innovating at that 15% or above even, because other sectors have managed that, but not slipping down to 12 or 10 is a real important message here. And so the market pool mechanisms do need to be country-led, but in order for them to be successful, then innovation is really key. And so the policy messages, and I've cut these straight from the report, and I will make the report available so you can read it in more detail. The market pool mechanism is the real foundation of making these deployments happen. It does need to be led at a country level. It needs to be put in place almost immediately in order to meet those overall 2050 targets. but it does need to be coupled with one of the accelerated innovations in order to make sure that we accelerate those cost reductions. And what they've highlighted there is, although the market pool mechanism does need to be led at an individual country level, there's a huge opportunity for the innovation to be collaborative across the international community, because the technology challenge that we have here in Europe is very similar to that in Asia or in North America. There will be slight changes, but the bulk of those innovations will be very, very similar. So the opportunity for international collaboration in order to accelerate that innovation journey is really key, and it's a real opportunity. So market pool, country-led innovation, international collaboration is a real opportunity. Then moving then to the deployment of these technologies and the supply chain. So we are going to require the supply chain companies that build and maintain these devices, but we're also going to require the ports and harbours where the overall assembly and the deployment happens and the operations and maintenance happens. And they've done a look at this, and what they've found in their analysis is that actually, because of the ramp up of this sector, for the next, let's say, 5 or 8 years, the overall requirements for the sector are reasonably modest, and we can use existing ports and harbours facility. But by the time you get to between 5 and 10 years' time, there's this real ramp up of the sector, and so we need to make sure that this does not become a bottleneck in the future. So there is an investment requirement, and although we have this like 5 to 10 year buffer, 5 to 10 years is about the deployment time for the investment in infrastructure, such as a new harbour. So actually, you do need to be strategic in that and start that planning and investment in infrastructure building or refurbishment now in order to ensure that it isn't a bottleneck in the future. So again, I will sort of take the quote straight from the report, and as I said, it will be available to you. Before I do that, they have done a study that said if you have a port with a throughput of around 300 megawatts per year, then you would require around 100 of those globally. Clearly, those don't all need to be new ports. Many countries already have an industrial infrastructure, whether it be from oil and gas, whether it be from mining, that can be repurposed. But if you were to have to build new ports, it would be around 100. So that's the opportunity that's there for countries that sort of invest in that infrastructure, have the ability then to seize some of those very significant prizes that I spoke around. So again, taking the policy guidance quote there, we do require a proactive approach to infrastructure development, because although the existing infrastructure will be fine for the next 5 to almost 10 years, the rapid growth that we will have in this sector in the future means that we need to start planning now for that. And now finally, the regulation and legislation for the consenting of this technology. Almost, this is not unique to the ocean energy sector. Any energy sector faces challenges right now with regard to the speed in which they can get consenting in place for their projects. And as I said, ocean energy, wave and tidal is no different. But what in the analysis that the IEA has done, they've looked and said there is an opportunity because of the sort of the small scale up of this technology. There's an opportunity to leverage the information that already exists around the world from test sites and the information that should give regulators comfort. They've looked at the different regulation and consenting regimes around the world and found that there are some very good examples, Scotland included actually, that have one window committees or one-stop shops. There is, because of the international nature of this sector, there's a huge amount of data being gathered by countries around the world, including the IEA members. And so there is the opportunity to share that data to reduce some of the regulators' concerns. And because of the ramp up of this technology, it's not binary that you have like one device now and then you have a very significant power station immediately. There is a ramp up of this technology. Then adaptive management is a real opportunity for the sector to accelerate and simplify its consenting regime. So again, the takeaway message here is that the regulatory message framework should help, not hinder, And although it needs to be robust, there are a number of opportunities to make sure that while being robust, we can accelerate with the consenting of this technology. So I will start wrapping things up now, but I'd just like to leave you with a reminder at the international level, there are significant prizes of very significant deployments and market share that is expected to happen between now and 2050, 300 gigawatts of deployment, very significant opportunities with jobs and economic benefits for the countries that embrace this technology, and of course the carbon savings. But none of this happens on its own. We do need those market pool mechanisms that are the foundation led at a country level. Accelerated innovation is really key to enabling that the sector becomes a success. Although port and harbour infrastructure is fine for the next 5 to 10 years, we do need to start planning now. And there are opportunities to collaborate, perhaps with other sectors that will require infrastructure as well, such as offshore wind that we heard about from Michael at the beginning, and making sure that the regulation and legislation framework helps, not hinders, the deployment of this technology. So hopefully that gave you a sort of a step back for the international opportunity and the international requirements. So thank you very much for your attention, and I'm happy to take questions in the panel at the end. Thanks. Back to you, Michael.
Thank you, Professor Henry. Round of applause, please. Okay, so now with that message of having market innovation, infrastructure, and regulation and policy. So I think we have our last speaker, who is our master mariner and a retired Rear Admiral, Nick Lambert, a co-founder and director of NLAI International, to talk to us about the blue economy. So let's see how we stitch all of these things together. Good afternoon, Nick. Can you hear us? You're on mute, I think. Yeah, okay, there we go.
You're loud and clear, Mike, and good afternoon.
Perfect, okay.
Everybody. I realise I'm the last person between you and heading down to Boat Quay for your Friday evening. Mike, we're pressed for time, I guess.
It's okay. We have the Q&A. We have until 4:30, but if you could do 8-10 minutes at most, Nick, on your blue economy slides and presentation, that would be much appreciated. Thank you.
I'll rattle through quickly then. So good afternoon, everybody, and thank you very much indeed for the previous speakers, who I thought gave a fantastic overview of marine renewable energy. I'm going to take you back to some of the points that Mike made, and just remind you of how vital our sea spaces are. So down here on the left, you see the Spillhouse projection, which shows that we have one ocean. It's a misnomer that we have 5 oceans and 7 seas. We only have one ocean. It's all interconnected, and it's vital to our climate and our environment. And we can see the whole of our planet now in great detail. So we know the damage that we've done to it. We all know in this room, I'm sure, the vital nature of the sea for us, the communications it provides, the power it provides, the protein, the water sources, the global logistics network that works because of the sea, and of course, fishing and so forth. And one of the big takeaways from the slides of our previous speakers is the amount of space and equipment and materials that are needed to install all these systems, not so much on the high seas, but in complex sea basins. So in your own part of the world, around the Malacca Straits and south of Singapore, hugely complex sea spaces where we want to put in these enormous systems. And so there's a complexity taking place, which is driving us to understand our sea spaces in a different way in the context of the blue economy. And it's also driving us to think about multifunctionality. And one of the things that hasn't been talked about by our speakers, and I'm not criticizing them, I'm just bringing it as highlighting it, is they haven't talked about multifunctionality. None of them has said, I'm going to combine this with aquaculture, or I'm going to declare this as a marine protected area. I'm going to gather marine environment data. Mo Ocean talked about providing energy for specific purposes, but nobody said, I'm working with a fish farm and I'm integrating the power generation system that I've created with fish farming, for example. That's not to say they're not talking about it, they just haven't mentioned it. And this is where the way the conversation is going. Also, we are all hugely concerned because we can see our planet in the way that I described. We're hugely concerned about what we've done to our ocean We have caused so much damage to it over the years that this is a really, really significant issue. So many of the problems that we face, such as ocean acidification, the answer to those problems lies in the continental shelf waters and the complex sea basins that I mentioned, in how we manage those sea basins, how we manage our activities there, and how we do something about regenerating the marine environment. So one of the things that anything that anybody does at sea should regenerate the marine environment. Because so far we've had a take, make, and dispose attitude to our ocean. We take stuff out of it, we make stuff with that stuff, and we throw it all back in. That is not sustainable. It's not living within the means of our environment, and that is something that we have to address. And the blue economy is part of the answer to that. This is the UN slide that Mike showed you at the beginning. The word that's missing in here, it's mentioned in the text, it says restores, but actually we need a regenerative and sustainable blue economy. We mustn't do stuff out in the ocean that just sustains the ocean in the state it's currently in, because we've already damaged it. Whatever we do out there needs to regenerate the marine environment in a sustainable way, so that we can derive that social and economic benefit that Mike described, but also regenerating the environment. We'll never get it back to where it was. It'll never go back to its original pristine state. And in fact, it was always changing anyway. But we can regenerate it and make it far better. We can restore wild fish stocks. We can use aquaculture in a better way. We can be cleaner in the energy that we produce. The infrastructure that we put into the sea space can be designed to regenerate the environment. Just taking a step a bit further now, my point about multifunctionality, it has been proven by various studies that the only way we're going to achieve this multifunctionality is by working across sectors. So if there's anybody in the audience there who has experience of being a fish farmer, a wind farmer, has worked with tidal energy, and has been involved in ecotourism, and really understands marine protected areas, please could you contact me, because you'll be one of the few experts in the world that has that knowledge. We have to create a different kind of person. We have to have training and capacity building to create people who can think in a multifunctional way, and to bring together the sheer complexity of that. You heard from Henry, you heard from our previous speakers, how complex their individual areas of expertise is. Think how complex this multifunctional approach is going to be. And this is why, working with ADB, I've been consulting with ADB for a while, we're now thinking about how we bring this together. How do we combine aquaculture, reefs, renewable energy, ecotourism, and so forth in a multifunctional way in a confined, complex sea basin? And this concept of flows extends from a study we did with ADB in the last couple of years, which focused on marine aquaculture, renewable energy, reefs, and ecotourism for ecosystem services, MARES. ADB loves long titles, but here we are with the sort of the power technologies that we were talking about earlier. How is that power used? It's a means to an end. It's not the end in itself. And so how do you use this power to X? And I'll talk about power to X in just a second. How do we use this power to transform the economies of island and coastal states and link together these different elements that I've been talking about? You can conduct electrolysis, you can use the water for all sorts of different purposes. You can use the energy for all sorts of different purposes. You can regenerate the marine environment, and you might even be able to produce a product. You might be able to produce hydrogen, for example, for export. So that was the logic of the MARES project. And forgive me if I just take you into a detailed sort of process here. So on the left here, we've got all sorts of different renewable energy sources, and we've heard of many of them today. We've seen that many of them are pilot stages, their initial operational capability, their various level of TRL. They've got to be scalable. They've got to be something that really produces that cost-effective energy and actually produces power to X. So there was a question in the audience right at the beginning about why is Singapore generating more than 100% power. That additional power can be used for other things so that you can power your economy of an island state. You can transform that economy because you've got the additional power. But to do so, you've got to think in the long term. You've got to have credible business models. You've got to have the funding. You've got to have the legislation and the governance to allow it to happen. But eventually, in the marvelous world of Nirvana that I live in, you end up in a positive feedback loop where you've got power to X, you've got more power than you need for your basic day-to-day economy. So you're creating alternative fuels, sorry. You've got exportable crops. You've transformed and digitized your economy, and you've got vibrant, regenerated and sustainable coastal zones. And so along the bottom line here, going back to my earlier point, you've gone away from take, make and dispose to a scalable, circular, regenerative environment and economy. I've nearly finished, Mike. You'll be pleased to hear. Mike also put up a slide, I think at the beginning, I didn't quite see it, of the Orion vision. This is the Shetland Islands, north of the Orkneys, which have been mentioned, where a very small community, 22,000 people live in the Shetland Islands, a small council that runs it. They have a concept for totally converting the island to zero emissions energy using their massive, they've got up to nearly 4 gigawatts of power, of wind power, about 1 gigawatt on land and about 3 gigs offshore. And they want to use that power to X to build methanol and ammonia plants and H2 plants to transform Sullom Voe, which is a major oil and gas port, into a zero emissions energy exporting port, to change the whole of the economy, the local economy, which is tiny, into a zero emissions port. They've got an interconnector to the UK. They're prospecting one to Europe, and they want to export hydrogen and also run the extant oil and gas infrastructure. So they've got this fabulous concept. They've done a lot of work on it. What's the challenge? It's the complexity of it. It's the expertise. It's the training and the knowledge and bringing together all those great big beasts, the wind power guys, the shipping guys, the port guys, bringing them all together and getting them to work in this multifunctional way. But it's scalable and it's regenerative. So just to recap, we've got to move away from that take, make and dispose approach to the multifunction approach that I've described based on zero emissions energy. Technology is not really the issue. You've heard that we're sort of we've only got 30% to go. You've seen shed loads of technology. I don't think technology is the issue. I think the issue is us, the human beings, our cultural approach. We don't think in this multifunctional way. And there's a very good reason for that, because the worlds that we're in are very complicated. And because we don't understand those different worlds, we are risk averse, and that makes investment different. So this needs really significant leadership. We need to be ambitious, we need to have integrated planning, and we need investment. And I suppose the final point I'd make is that what we're trying to do is to get terrestrially minded investors to understand that these magnificent opportunities are available in our blue economies. Mike, I'll shut up at that.
Thank you so much, Nick. Round of applause to our last speaker. So maybe as we go into the Q&A session, our colleague has given you some small post-its or papers to write on your questions. I invite my panelists to please turn on their cameras, and I ask our IT folks to please show all our panelists. Feel free to stretch a little bit, stand up if you need to regenerate a little bit of your physical bodies. There we go. So we can see the panelists now on screen. So again, we've got James, who spoke about offshore wind. We've got Cameron, who spoke about wave energy. We've got Andrew, who spoke about tidal energy. We've got Henry Jeffrey, who spoke about ocean energy systems, policy, and international collaboration. We've got Nick, who spoke about the blue economy. So I'm gonna ask folks who may just want to raise their hand and ask questions, please do so. If you're shy, you can write it and I can read it from here, no problem at all. Yeah. So we've got a number of questions here, guys, but I'm going to start off with a few of them. So there's a cluster about the technologies being emerging, right? Where is the cumulative expertise? And how does remote small islands, we have a lot from the Pacific here, access such expertise? So I'm gonna do one quick round, if you could. Maybe, I think, Professor Henry, could you take that? I think you've had a lot of experience in this space. Since they are emerging, where's the cumulative expertise? Of course, you're gonna say Scotland, but could you please expound a little bit more as to where else, and how do remote small islands access this expertise?
Yeah, no, of course, it's a great question, Michael. And so, of course, we have considerable expertise in Scotland, but that is, predominantly around the development of the technology, of developing these emerging technologies of wave and tidal. But as I said, I'm wearing the hat today from the International Energy Agency, and we have 23 countries around the world, including Singapore as a member. So 23 countries that all have a significant interest and all have some level of expertise. But it's not just the expertise in developing the wave and tidal device itself. There is expertise in the supply chain of the components and subsystems that go into those devices. And some of those subsystems are not emerging. Some of those are reasonably mature, whether it be the power takeoff or the control system or the mooring. So that sort of supply chain expertise spreads throughout the world very, very significantly. But when it comes to islands and what expertise they can build, of course, if you are deploying the device on an island, and then you're going to gain the expertise of the deployment, the operation, and the maintenance, that comes from that act happening. And so, although you might say, well, as an island, we don't have the supply chain that is going to build the electrical generator, but it's very likely that you can train and train skilled technicians to operate and maintain these devices. So the supply chain opportunities, is spread around the world, but the opportunity for islands is really very significant as well. Because as we move to having significant deployments in the future, a very large part of that value chain will be the operation and maintenance of those devices. Hopefully that helped, Michael.
Yeah, thank you so much, Henry. Any other speaker wants to add to that? Very quickly. Cameron, your lips are moving, but we can't hear you.
Sorry, can you hear me now?
Yeah, we can hear you now. Yeah.
Okay, sorry. So from our perspective, for example, I went to French Polynesia a couple of years ago on a bit of a sort of scouting trip, and there's very much a desire for having these technologies, in that location, but very much a sense of the companies developing these technologies are halfway around the world. So I think it is a real challenge to figure out how we get technologies developed in Europe and America primarily, over to the South Pacific, to Southeast Asia. I think that's just something that we need to think about, how we connect these two things. And then, to Henry's point about training people locally, absolutely, but I think we don't get that knowledge unless we do demonstration projects. So I think there's a real need to do collaborative demonstration projects, bringing your Scottish technology, whatever, to Asia and actually doing that.
Okay, thank you so much for that. I'm going to move on to the next question, guys, before you add more. So considering these RE solutions, what are the nature ones, or where are the nature-based ones that could be integrated? Nature, mature. Where are the mature ones in terms of the RE solution? We cannot be testing fields in pigs. Is that right? Yeah. So that's a question. Which ones are mature? And could you comment? We mentioned pre-commercial. Those are commercial. Which ones are mature now? Maybe those that are applicable to islands at the moment. Yeah. James, you want to?
Michael, I'll jump in. So
Andrew, okay, go ahead.
I would argue that tidal energy has been in the water since 2015. You know, for almost 10 years, we've had devices in the water producing energy. You know, these are robust, reliable sources of energy generation. So I wouldn't, although they are pre-commercial in stage of we haven't, you know, and even they are not necessarily pre-commercial because we've been awarded contracts in the UK to deliver devices and be subsidised. So I think it's an historic view that these are not yet commercial. These are devices in the water with ours and with commercial contracts now. So we need to think of them as not established but mature technology that is going to be able to develop work on islands around the world, delivering power to where it's needed. So for tidal energy, I think the time is now, and you can fit it into existing onshore wind, onshore solar. So it's part of a system. It's predictable, and that's the key about tidal energy. It's predictable. We know when it's going to be there, so we can have batteries and create it as a base load for some of these island communities.
James, you wanted to add a little bit on that?
Well, still the most mature technology is fixed offshore wind. Obviously, you can have onshore wind as well. That's by far the biggest installed capacity, has been operated for 20 years, has the lowest ongoing cost per unit of electricity. So that is the biggest player in the sector by far.
Yep. Comment on that, Nick, in terms of the perspective of mature technology versus up and coming?
I agree with everything our speakers have said about the maturity of the systems. Fixed wind is clearly one of the most mature. The tidal one is interesting because of course this is such a difficult environment. So the fact it's been in the sea now for 5 to 10 years is good. But it's the scalability of this, and then there was the question around the ability to maintain systems, and I think it's easy to underestimate that. Island communities have the expertise to run their countries, but they don't have the expertise necessary to run these additional capabilities. So it's got to be pretty robust and relatively simple and proven technology, so that you can build the capacity in the local community to keep these systems running. And I think that's an area which is we're better understanding now. So it's a very significant undertaking.
Thank you, Nick. I'm going to shift to another question. I'm going to ask our IT folks to maybe also put as panelists the camera that's viewing our audience, because they are part of the panel here. Yeah, say hi again later once you see yourselves there. So we've got the technologies mentioned, you know, floating PV, offshore wind, wave and tidal, and so many possibilities. And there's a question here from the context of the Pacific. Surely it's possible to combine a lot of these technologies and demonstrate it probably in one site, ? Let's say if it's an appropriate site, you know. Could we look at case studies, examples that we know of that have been done before for multiple technology options coming together in one site for specific applications, plural? Any comment on that, maybe? Go ahead, from any panelist.
I mean, I would say I'm not quite clear, you know, whether the context of the question is about sort of a commercial application or is it about testing. I mean, you know, at EMAC, the European Marine Energy Center in Orkney, it tests wave and tidal, and then they've kind of expanded that to do, you know, as you said, Mike, hydrogen and all sorts of cool things. So I think, you know, I mean, what would be a brilliant idea is to have a sort of similar test center in the Asia region for these types of technologies, bringing them together, and then having that in the island context. There'd be an incredible amount of learning through that. But you know, I think on the other side of it, for commercial projects, the whole idea of combining different renewable energies is incredibly important. I mean, that's how you deliver a reliable, robust energy system. You have different types of renewables and energy storage, and that's how you keep the lights on all the time. And that's, you know, what we're doing with our product. We're combining wave and solar, but, you know, you can extend that to having other types of renewables in the same region.
Okay, Andrew, I'm going to point to you then, Henry, about the markets, you know, for ocean energy or combined systems, microgrids, etc. Is it water or aquaculture? Have you had experiences in technology development as well as, you know, the market pull side of things? Yeah, Andrew?
Yeah, I was going to echo what Cameron said. We're seeing this on Orkney and also bits on Shetland, where you've got lots of different forms of renewable energy. So as we said on Orkney, you've got tidal, you've got wave, you've got hydrogen, you've got onshore wind. They're all combining into an energy system that has historically had problems with the grid connection. I know there's a new grid connection coming, but we've showcased on those islands and for EMEC that these things can all be done in harmony together to create a really interesting energy system. And the same with Shetland. Shetland was an islanded grid, so it had to support itself, and it's done that with tidal energy, with onshore wind. So it's shown that actually these devices, these different forms of renewable energy can all work together really well to create a stable grid system for an island. And so, but it would be interesting to see that at a test site somewhere in the Pacific to showcase that it can be done in other parts of the world. But it is viable and has been done.
Thank you, Andrew. Professor Henry?
Yeah, no, those are, I agree with everything that Andrew and Cameron have said. And I think the islands are, you know, there is a significant opportunity because islands are, the challenge they have is a sandbox of the rest of the energy system. You know, the challenge that an island has is just a mini version of a challenge that the larger energy system has, but it's just more extreme because there isn't perhaps the opportunity for interconnectors there. And so having that, you know, combination of technologies is extremely attractive. They're making sure that, because if you are an island relying on diesel and you say, okay, I'm going to replace that with tidal energy, you're still going to have significant energy storage requirements. But if there is a solution which is tidal energy, wave energy, solar, and wind, then that becomes a much more attractive solution. And then the overall storage mechanisms become much, much more manageable. So there is a significant opportunity there, but it does link back to the previous question about maturity, because there is two levels of maturity that you need to consider. There is the technical maturity and there is the commercial maturity.
Technical
so
maturity and
I would
commercial.
say, yeah, so I would say that, you know, even though some of these technologies, wave and tidal, would still be classed as emerging, you know, at a technical level, they really are quite mature. They're just not as inexpensive as other technologies, and so they're classed as emerging. And so because it's a very different cost level, cost benchmark that we're at in islands, then some of these technologies that we're classing as immature in the broader energy mix for utility scale, you know, continents, they are actually much more mature when you consider their application in islands from the financial commercial maturity perspective.
Thank you, Henry. I think Nick, your hand was up, so I'm going to call you. Yep, please go ahead.
I was just going to really pick up on what Henry's just alluded to. This market pull, the commercial pull, and government pull. I think the technologies are rapidly maturing, and they're on the cusp of being really viable and generating consistent, cost-effective power. But I've just come from the UK Caribbean Trade and Investment Forum in London this week, and the island states there were saying, look, climate change was caused by somebody else. We're right on the front line of it. We're burning diesel at very high cost. We're being driven towards zero emissions, and no, we just don't have the capability to bring all of these technologies together to create the grids and the economies that I described for our islands. We simply don't have that. So there's this dichotomy between these fabulous technologies on the one hand, the fact that we can physically make it happen, and yet how do you bring in the investment? How do you bring in the leadership and the governance to make this happen? And that's the fundamental challenge, which is why I said in my presentation, I don't think it's the technology that is the issue. It's our culture and it's our stovepipe nature of doing business, which is the challenge. And that's, that sounds really negative. It's not, because people are now talking about it and we're starting to see it. But you're going to have governments that say, I am going to transform my economy in this way, and I'm going to bring these different technologies together in a multifunction approach. And that's why I'm so chuffed to be working with ADB in the emerging areas and what Cindy's trying to achieve, because it's those sorts of agencies that are going to provide the risk mitigation funding to kick off these sorts of projects. But as I kept saying several times, and I'll just shut up in just a second, you've got to have the people who can make it happen.
Yeah, thank you so much, Nick, those panelists. So I'm going to go into maybe last couple of questions, but I'm just going to make a comment. You know, a few years ago in the European Marine Energy Center I visited, they had a site which was called the full-scale test site. And then they had a site that was called a nursery site. And I said, what goes into the nursery site? Oh, anything that's, maybe 100 kilowatt, 50 kilowatt, maybe 150 kilowatt. And the full-scale test site was sort of in the megawatt range. Little did they know that the 100 kilowatt was already the full scale for many markets, like the Pacific Islands, for technologies that they were just test bedding. Because we don't need 1 megawatt systems for islands that probably have maybe less than 1 megawatt of demand. So some of the test bedding technologies that they were after in their nursery sites could actually already be translated as pre-commercial, even commercial, maybe financially, commercially mature for some of the island states. Now, on the island states, one of the ministers mentioned to me that he hated the term small island developing states. He said, we should not be called that anymore. We should be called big ocean states, bosses, not small island developing states. Investors will never come to us and never invest money in something that is termed small island developing states. Why don't we change it into big ocean states? Not large ocean states, because that spells losses, but big ocean states, which spells losses. So maybe a question to the panel here. Knowing that the demand in these islands are not going to be a lot of hundreds of megawatts, right? But in the, decent sort of 1 to 10 megawatts, maybe, in a lot of these island nations, what would be the impetus for us to have more marine renewable energy deployed in the order that is beyond maybe the current demand in terms of productive uses or export potential? Can you speak more about what are the markets that they could aim for in terms of exporting products and services beyond their demand right now? I'm gonna go around, if it's okay. Who wants to go first?
May
Go
I?
ahead. Go ahead. Yes.
Okay. I mean, I think the ocean and the stuff that we can do in the ocean holds vast potential. And as you say, these islands have much more ocean area than they have land area. So, for example, a couple of the kind of industrial things that could be done with that space of the ocean. I mean, people know about aquaculture and I think hydrogen is a big one. So, can we use
hydrogen? Okay.
Renewable energy from hydrogen? I think another thing is subsea data centers. So actually putting data centers under the water means that it reduces their carbon footprint, and actually it's much less expensive to install a communications cable to an island than it is to install a power cable. So you can have your data centers near these islands in the water, powered by renewable energy, and export the data. And then the final one, if I may, that I really like is this idea of a direct ocean CO2 capture. So this is just like direct air capture, where you're pulling CO2 out of the air, but you pull it out of the ocean, and there is more CO2. There's a higher CO2 density in the ocean, so it's more efficient to pull it out of the ocean and to power these systems. So you pull it out of the ocean, then you sequester it. but to power these systems, you can use renewable energy. So there's lots of really cool stuff that's going to be happening in the blue economy that would benefit from blue renewable energy.
Thanks, Cameron.
Yeah,
Andrew?
so just to jump in, we're doing, the university's got a partnership with the Galapagos Islands, so we do a lot of work there. And some of the stuff we're looking at is how do you help an island that is growing and developing, but doesn't therefore doesn't want to undermine its biodiversity? You know, we know the Galapagos is very special in those sort of terms. So we've been looking at all kinds of things about how do you make sure, how do you help them not import diesel and water? So how can you use the renewable energy we're going to generate on that island to help them look at desalination of water, looking at providing energy for the boats that will go between the islands, look at providing power for the hotel. You know, it's still a big tourism location. So, but by providing renewable, sustainable power for all these different elements, we're helping them thrive sustainably as an island. And so working with what their demands are, what their needs are, how they're trying to grow and develop. So it's really trying to, it's a bigger question because it depends on each individual island and what their priorities are. But this sustainable renewable power for marine could really help that whole sector. But it also requires things like making sure the grid's correct. And there's lots of elements, but we're already showing that we can do those things and help those big island states in terms of working through things and growing and continuing to develop.
Thank you, Andrew. James, would you care to share your thoughts?
I think that if the island states are close enough to be networked together with power cables, then this network can be an important element of distributing excess power, load sharing, combining different systems. So you may have a state where the potential for tidal power is higher and it generates more tidal power and times it will export to other islands. So the idea of an integrated network with multiple renewable energy sources and storage capacity can be really important if the islands are close enough to be networked efficiently, cost effectively.
Thanks, James. Henry, any thoughts?
Yeah, no, I do. I think that, you know, going back to my previous statements, is that because the commercial model is different and the opportunity, these technologies are more mature in the island conditions from a commercial perspective, there's a real opportunity that these islands then become the early adopters of these technologies, and not just the wave and tidal, but bringing them together into a microgrid with other technologies. And so, given that there is no one country or no one company that is the global expert in there, the opportunity for islands becoming experts in the installation, the operations, the maintenance and the recovery of these technologies is, I think, very significant. And then, so the economic prize that's there for doing that, and then potentially the economic prize for exporting some of those technologies, I think is really quite significant. You know, I take on board, you know, Nick's point that sort of currently, you know, that expertise doesn't exist in the island, so it would require some, you know, investment to ensure that capacity was to grow. But I think it's an area that it's not as if we're asking them to become expertise in gearbox manufacture, but to become experts in like the installation, the operations, and the maintenance. I think that's a very realistic prospect for the economic benefit, potentially the export of that economic benefit from island communities.
Okay, good. Exporting expertise back to Australia, maybe from the Pacific. That's thought. Yeah. Okay, Nick.
Mike, I'll just say that Singapore is a boss. And
Singapore is boss.
Is a boss. Singapore is a big ocean state, albeit with a very small sea space. And it has 5.5, 6 million people on it. And many years ago, its prime minister said, the secret to our success in Singapore, the transformative technology in Singapore, was air conditioning. So you must have brought in zillions of people and trained them to install and operate air conditioning, and you now have this incredible economy. And so Singapore is the right-hand edge of the potential for all of these island states using power to X. So the question of what can we do with it, I thought Cameron got exactly right. You can do all those things, but there's a zillion other things we haven't even thought about. And you can think about, what are the things that Singapore does? Well, all these island states could do that sort of thing. And it's having that understanding of how you transform your economy. So many of them, by default, their economies are blue economies. And I'm hoping that in time, before I'm put in my box, we'll stop talking about blue economies and we'll just talk about national economies. And by default, that will incorporate the blue economy.
All right. Thank you so much. I'm going to give you guys a minute to think about final words. Keep it to 30 seconds or less. I'll ask our IT to please flash our one screen of slides just as a reminder as we come to the end of the webinar. It's an alert, right? But the yellow alert. So we will have the materials be made available in this site, which you can scan the QR code. We'll also send an email just for your convenience. The 5th knowledge sharing series will be sometime in December. We're scheduling something around what you've learned today, digital, data science, and AI, but specific to operationalizing these innovations for the power and energy sector. Some things are more downstream, real applications and use cases by real utility companies as well. So I'm going to go back to the panelists now and ask them for their final words. Let's do it in sequence. James, can you go first? Thank you.
Sure, thanks so much. It's been a great meeting, thank you. And we've seen an astonishing increase in the amount of installed capacity of renewable energy in the last 2 years. That's only going to grow further. There's immense potential for this in the Asian Pacific region, being led by China, Taiwan, South Korea. Other countries are getting into this market too. So think about it in an integrated manner. Think about multiple sources of renewable power. Think about issues like grids and ports and skills and training, and plan ahead. Thank you.
Thank you, James. Yeah. Okay, Cameron.
There is energy is an enabler. It's not an end in and of itself. Small island developing states, as you say, they're big ocean states. The ocean is their biggest resource. Getting energy from the ocean can, provide power for people to live, but also can help to transform them in the productive utilization of these oceans in all kinds of really sort of cool and exciting ways.
Okay, thanks, Cameron. Andrew?
Yeah, I would like to, just continue to challenge people's opinion on tidal energy. It's been in the water for 5 to 10 years producing renewable electricity. And tidal energy can be part of a really interesting energy mix on island states to really help power them and to help meet those aspirations. As Cameron said, it can be transformative for these states, and it's just trying to come up with innovative solutions using this tidal energy and wave and offshore wind to try and help revolutionize and help develop these states.
Okay, thanks, Andrew. Professor Henry.
Yeah, first of all, Michael, thanks for doing such a great job of chairing this and for the Asia Development Bank for offering this session. I found it extremely useful and enjoyable. My final comments would be to remember, although we've been speaking a lot about technology today, the real resource here is the ocean or the sun or the wind. But that, I think, is even more trumped by the main resource here is that this sector will be driven by people. And these big island states, have the resource and they also have the people. And so making sure that you make best use of that resource that you have in the people, business as usual will not be the way forward here. We want to think about what we would like to happen and what do we need to do differently to make that happen using the people as a resource.
Thanks, Henry. Yeah. Nick?
Thanks, Mike. I iterate Henry's thanks. We're the converted. I think we should all go out there, think multifunctionality, be ambitious, go out there and tell your governments and tell your investors that these opportunities are there. Tell the story, get them excited and get them involved. Because until those big investors come in, we're we're going to be on the cusp all the time.
All right. With that, again, my name is Mike. Thank you so much for having this webinar. Thank you all panelists. I think everyone deserves a big round of applause for making it through the week. Yeah. And maybe final words from Cindy before we end. Cindy?
Thank you, Mike.
Whoa, echo.
Sorry. Yeah.
There you go.
It must be my mic. There you go. Okay. So again, thank you everyone. Thank you. Please give another round of applause to our panelists and our speakers.
Yes.
Very wonderful. A lot of learning today. And thank you for all who have stayed until the end. And thank you for your cooperation and your engaged participation. Please do not hesitate to talk to us. You have our colleagues there in the room, and also send me an email about your wish list. I think we talked about this before I left. So please do let us know in whatever way the ADB can help. And of course, we can network with other donors and development partners to help you get to resilience. I think that's the main aim for the Pacific Island countries, to be sustainably developed as well as resilient to the changing climate. Thank you all, and thank you again to the speakers. Have a great weekend.
All right.
Safe travels, everyone.
Okay, so with this, we end our webinar. We end the week and hope that you've had a good, full load of learning this week. May you have a good rest and a great weekend ahead.